definition of solenoidal is nothing but a vector f is said to be solenoidal if divergence of that vector is 0. Okay. Similarly, if the irrotational f is said to be irrotational if curl of f equal to 0. Okay. Then we can also call that vector f is also called as conservative field or potential field. Okay. If the vector having curl f is equal to 0, then we can say that vector field as conservative field or vector field or potential field. Okay. And if f is an irrotational, then we have a scalar function phi such that okay, f will be equal to del of phi. Okay. So this phi is called scalar potential of that vector f. Okay. So let us again repeat. A vector f is said to be solenoidal if this divergence of vector f is 0. Okay. So this is the definition of solenoidal. Similarly, if the curl of f is 0, then it is said to be irrotational vector field and it is also called as conservative field or potential field. Okay. Suppose if f is irrotational field, then there exists a scalar point function phi such that del phi equal to phi. Okay. So we are going to do the problems based on this statement only. So first we'll prove vector is irrotational and then find scalar potential for that vector. Okay, so let us see how to do that. So this is our problem. Show that if vector f is irrotational, also find scalar function phi such that f is equal to del phi. Okay. So first thing we need to prove here is nothing but given vector is irrotational. So irrotational means curl f of that function will be 0. Okay. So let us see. Given vector f is equal to y plus z into I plus z plus x into j plus into k. Okay. So we need to show that this vector is irrotational. Okay. For let's say what we need to find curl f is equal to, how to define this? Del cross f, right? Curl f is nothing but del cross f. So this one is equal to determinant of I, j, k. So dou by dou x, dou by dou y, next dou by dou z, next y plus z, z plus x, x plus y. Find the determinant for this is equal to I into so just do the differentiation dou by dou y of x plus y minus dou by dou z of z plus x minus j into dou by dou x of x plus y minus dou by dou z of y plus z plus k into dou by dou x of z plus x minus dou by dou y of y plus z. Okay. So this one is equal to how much you'll get, let us see. So differentiation of x plus y with respect to y, how much?
1.
So you'll get 1 minus, with respect to z, if you do, again 1.
Minus.
Again 1 minus 1. Plus k into, again 1 minus 1. Okay, so we got 0. So curl f, we got it as 0. Okay, implies when curl f is equal to 0, then f is called irrotational vector field. Okay, so if it is a irrotational vector field, implies there exists a scalar function phi such that f is equal to del phi. Yes, Akshay, what's your doubt? You have raised the hand, right? Any doubt?
Oh, no, sir, by mistake.
Okay. So, if f is irrotational vector field, then there exists a function phi such that f is equal to del phi. So, we need to find such phi. Okay. So, if you want to find phi, what we need to do is we have to expand this equation. Okay. So, f value is how much? Y plus z I plus z plus x j plus x plus y k is equal to expand del phi. Dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Okay. So implies compare on both sides. Okay. If you compare on both sides, what happens? I quotient will be equal to I quotient. That means dou phi by dou x must be equal to y plus z. Similarly, dou phi by dou y is equal to z plus x. Next, dou phi by dou z is equal to x plus y. Correct. So we got the quotients dou phi by dou x, dou phi by dou y, dou phi by dou z. Its quotients in the left hand side. Okay. Now, if you want to get phi value, what we need to do? You have to apply integration on both sides. Correct. So you have to apply inverse operator. For differentiation, inverse operator is integration. Okay. So integrate on both sides. Integrate on both sides. So if you integrate on both sides, left hand side will get phi is equal to integration of y plus z with respect to x in the first one. Okay. So what happens? If you integrate with respect to x, y plus z is constant.
Y
Integration
plus
of
z
1.
whole in
Huh? Yes?
y plus z into x.
Into x. Okay. Plus integrating constant you have to do. See here you are integrating partial derivative. Whenever you are integrating partial derivative, you have to write integrating constant as function in terms of other variables. That means y comma z. Function in y comma z you will treat as integrating constant. Clear? Since suppose if you are performing differentiation integration for this derivative, okay, some a. If you integrate for ordinary derivative, you will get y is equal to a plus c or c1, where c1 is the integrating constant, right? Since y is a function of some x, so it is function of only one variable. So If you integrate for that kind of function, you'll get number as a integrating constant. Okay. Similarly, if you are integrating partial derivative, then you'll get a function in terms of other variables. Okay, is treated as integrating constant. So that's why I have written f1 of function of y comma z is the integrating constant, and we have to find this integrating constant. Later we'll find. Okay, so this is for first equation. Okay, for second equation, if you do, what happens? Integration for this z plus x, you are integrating with respect to y for the second equation. What happens? Integration of 1 dy is y, right? Plus function in terms of z comma x is treated as integrating constant. Next, if you integrate third one, phi is equal to x plus y into z variable plus f3 of x comma y. Except z, we have to take other variables, other two variables as constants. So function in x comma y is treated as constant. Okay. Now, in keeping this aside, now if you compare these three equations, comparing above equations. Okay, if you compare above equations, all these phi are same, not different one. So, what will be the value of f1 of y comma z? Okay, compare these three equations, or let us write one more step here so that you'll get clarity on this. So this one is equal to, I can write this one as xy plus zx plus f1 of y comma z. This one is equal to zy plus xy plus f2 of z comma x. So this one is equal to, I am multiplying that z. So xz plus yz plus f3 of x comma y.
Sir, can you re-explain the integration?
Integration. So here in the next slide I will explain. So what we are having, dou by dou x of phi is equal to y plus z is the first one, right? Okay, if you integrate on both sides, dou phi by dou x into dx. Okay, next integration of y plus z into dx. Okay. Now you are integrating a partial derivative of with respect to x. Okay, integration with respect to x you are doing. So this will be phi. Okay, so this one is equal to y plus z, I am taking common, integration of 1 dx. Okay, so this one is equal to y plus z, integration of 1 dx is how much? X, right? So plus integrating constant I am writing, since we are integrating partial derivative here. So we have to put function in terms of y comma z as integrating constant. Clear? So this only I have written in this previous step. Fine. Any doubts here?
No, sir, didn't understand.
Huh? What you didn't understand? Can you
That only
research
that
this?
how f1 of y comma z came.
That is what I am saying. Function of y comma z, you have to take it as integrating constant. See, if you are integrating with particularly any one variable, phi is a function of x, y, z, right? Is it correct or not?
Yes.
Huh? Whenever you are differentiating or integrating with respect to x, you have to treat other two variables as constants. Correct? Is it correct or not?
Yes, sir, correct.
So, whenever integrating or differentiating with respect to one variable, we'll keep other two variables as constant. Okay, integrating constant should be that function in y comma z. I have taken this as constant. Clear?
Yeah.
Function in terms of yz. I am treating it as constant. That's it. Not only f1, you can write anything here. g1 or g2, anything, any letter, but that should be a function of yz. That's it. Okay, this we are going to find that function. Okay, don't worry. So that also will be we are going to find. Okay. Yes, next. Our next task is we need to find these values. f1 value, f2 value and f3 value. How will I find means? These all three phi's are same. Correct? Because phi is a function of x, y, z. In the first derivative, we have differentiated with respect to x. Correct. With respect to y, you have differentiated. With respect to z, you have differentiated. But whenever you come for integration, all the phi should be same. Okay. So if all the phi's is same, then you have to able to identify function of yz in the remaining two equations. Okay. In remaining two equations, select the function which contains only yz. Which one are there? Here yz function is not, here is there, yz is there. Here also yz is there. Correct. But these two are same. Okay. You can take only one. Okay. So f1 of yz must be zy or yz. Okay. So to compare on both sides, comparing above three equations, f1 of y comma z must be equal to yz. Similarly, now I need to find f2 of z comma x. Z comma x function you have to search in remaining two equations. Okay. So here zx is there, here also zx is there. Okay. So f2 of z comma x must be equal to zx. Okay. Suppose in this function you are having 2z. Okay. Then you have to take zx plus 2z. But here these two functions are same. We are writing only one function. Yeah. So implies f2 of z comma x or x comma z is zx. Next, f3. How will you find f3? In remaining two equations, you have to search for x and y only terms. So here xy is there, here also xy is there. Okay, so if both are same, leave it, only take once. Okay, if those two are different, then you have to take addition of that. Okay, so if f3 of x comma y must be xy. So, comma f3 of x comma y must be equal to xy. So, therefore, finally we'll write the required scalar potential phi is equal to, write any one equation here. Okay, I am writing first equation xy plus zx plus f1 of yz is there. So f1 of yz is, value is yz. So this is the function which we are going to find. Okay, understood?
Yes, sir.
Any doubts here? So that unique phi value is this much. Even if you substitute f2 in the second equation, you will get the same equation, because f2 of z comma x, we found it as zx. Okay, you substitute it, how much you will get? Zy plus xy plus zx. So that only we have written here. Yeah. So only one phi value you will get. So if you write that one phi, then that is enough. Fine. Go through once again whole problem. If you get any doubts, you can ask me.
Sir, the last part once again, can you do, sir, after integrating?
After integration,
Yeah,
what
yeah.
we'll do is, after integration, what we did is, we have simplified it. Okay. Once we simplified it, we got integrating constants, right? To get the unique phi value, to get unique phi value, we need to find function yz, function zx, function xy. Okay. So to find this function yz, in this equation it is not available. I have to search for this function in the remaining two functions. Why? Because these three phi's are same. Okay, not the different one. Okay, phi has three different equations we got. Okay, so in first equation, if you are not getting function of yz, means you can search for yz function in the second and third equation. Okay, in second and third equation, what are the functions of only yz? You have to search for that kind of terms. Yz term in the second equation is this, and yz term in the third equation is this. Okay, compare these two equations again. If these two are same, then you can write only for ones. Okay, if these two are different, then you have to write it addition between those two. Yeah, so that's why you will get f1 of yz, value is zy or yz. So here I have written zy. Similarly, to get the remaining two, that means f2 value and f3 value. So to get this value, so what I did is, except this equation, I have compared zx function in the remaining two equations. So zx is there here and zx is there here. Correct. So compare these two again, whether these two are same. If these two are same, write only for ones. If these two are different, then you have to take addition between these two. Okay, so zx function in the remaining two equations is xz or zx. I have taken zx. Clear? Similarly, how to search for f3 function. So how to define f3 function here? Again, except the third equation, you have to compare remaining two equations. You have to search for xy function. So xy function in the first equation is this one, and xy function in the second equation is this one. And compare these two solutions again. If these two are same, then you have to write only for once. If these two are different, you have to add it and you have to write. Clear? So that's why we get xy function as f3 of x comma y is xy. So finally what I did, write any one equation among these three. Substitute that function value. Okay, so first equation I have selected. I have written xy plus zx plus function of yz. We found it as zx. Okay, so I have substituted it. So that is the overall solution for your given problem. Fine. Still any doubts? If you want, you can verify whether this answer is correct or not. How will you verify? He has given that del f must be equal to, f must be equal to del phi. Correct? So del phi is nothing but dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Okay, find out dou phi by dou x. How much you'll get? Y plus z according to this, right? Take this phi with differentiate with respect to phi. You get y plus zi. Again differentiate with respect to y. So how much you'll get? X plus z you'll get j plus differentiate phi with respect to z. So x plus y you'll get into k. So check whether given f and you have got f is same or not. What is the given f? Yz plus zx plus xy. Here also yz, zx and xy. So if this is correct, then this phi is correct. So this is the verification for your solution. Yeah. So in this way you can verify your solution also. Fine, we'll go for next one. Yes?
Yes, sir.
If you do one more problem, you'll get a clarity on this. Let us see this. So f is equal to this function they have given is conservative force field. Suppose if they give any word like conservative or potential field, that means we have to show that f is irrotational. So remember that. So f is equal to 2x y square plus yz into I plus 2x square y plus xz plus 2y z square into j plus 2y square z plus xy into k. Okay, so this is your given function. We need to prove curl f must be 0. So curl f is equal to, this is nothing but what? Del cross f, right? So del cross f means I, here j, here k I have written, dou by dou x, dou by dou y, dou by dou z. Okay, so x quotient, I quotient, that means 2x y square plus yz. Here I j quotient, 2x square y plus xz plus 2yz square. Next 2y square z plus xy. So this one is equal to I into, can I differentiate directly and put the solution? Will you understand, right?
Yes,
I am
sir.
going to differentiate directly and I am putting the answer. Okay. So I into dou by dou y of this you have to write. Dou by dou y of this will be how much? Dou by dou y of 2 y square z plus xy.
4yz
4yz
plus x.
plus x will get minus dou by dou z of this function.
X
So dou by dou z of this is minus x minus
4yz
4yz. Correct. Minus j into next.
Sir, in the beginning, I into
Ah.
4 x y z, no, sir.
I into 4.
No, sir, no. Proper.
Huh? What happened?
No, sir, I took it off second column, so it goes wrong. No, sir,
Okay,
proper.
okay.
Here is proper.
Okay. Ah. So j into dou by dou x. Dou by dou x means y you'll get here. Next minus dou by dou z. So we have only one term with z, that is y again. Next plus k into dou by dou x of this function. So that means 4xy plus z is there minus dou by dou y of this function. So again you'll get 4xy minus z. So all the terms will get cancelled. This and z minus z. So overall the answer is 0. So we got curl f is 0. So if curl f is 0, then we need to find scalar potential. Okay. So therefore vector f is irrotational. Vector field implies there exists a scalar field phi such that f is equal to del phi. Okay. So f equal to del phi means again you have to compare the equations. Using this equation we need to find phi value. Okay. So let us see this. So del phi means dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Okay. This one should be equal to 2x y square plus yz I plus 2x square y plus xz plus 2y z square j plus 2y square z plus xy into k. Okay. Implies compare on both sides. If you compare on both sides, what and all will get? Check once. Dou phi by dou x will get as I quotient here. 2x y square plus yz. Similarly, dou phi by dou y, you will get it as 2x square y plus xz plus 2y z square. Next, dou phi by dou z. You will get it as how much? 2y square z plus xy. Okay. Now integrate on both sides. above equations. Integrate above equations. Now, if you integrate first equation, that means you are integrating with respect to x. Implies phi equal to how much you'll get? 2y square is there. You have to integrate x. So that means x square by 2 plus integration of yz. So you have to keep yz aside. Integration of 1 dx is x. Okay. Plus f1 of function in y comma z. You are taking it as constant. Integrating constant. Next phi is equal to, from second equation you try. Integrate with respect to y you have to do 2x square aside. Integration of y is y square by 2. Next, plus second term. So in second term y is not there. So integration of 1 dy. It is y you will get. So xz into y. Plus one more y is there. So you will get 2z square into y square by 2. Integration of y is y square by 2. Plus integrating constant, I am writing it as f2 of x comma z. Okay. So because whenever you are integrating y, except y, you have to take remaining variables as constants. Correct. So that's why here x and z are constants. So I am writing function in x comma z as integrating constant. Okay. Similarly, one more phi is there. That means third equation. Phi is equal to 2y square z square by 2 if you integrate z plus xy. Integration of 1 dz is z. Okay. Plus integrating constant will be how much? f3 of except z, you have to write remaining two variables. That means x comma z, x comma y, x comma y. Okay. Now cancel these two equations. Sorry, these two. Any simplifications are required, I just do it. Here 2 to get cancelled. Okay. So wait a second. I'll add a slide.
Sir, once go back, sir.
Wait. I'll come back. Yes. What? Next, I will rewrite 5 values after simplification. So here I am rewriting 5 again. After simplification, phi is equal to how much you got? Y square x square, or I can write it as x square y square plus xyz plus function in y comma z. Next, one more phi we got it as x square y square again plus xyz plus y square z square plus f2 of x comma z you got. Next, phi is equal to one more function, y square z square. Next, x y z plus f3 of x comma y. Now compare above equations. We get, now I'll change the ink. So f1 of y comma z function we need. So if you want to find f1 of y comma z, don't check in this first equation, check in these two equations. Okay, so check only the function contains y and z, not other variable. Okay, so such kind of function is available in the second equation as this much. Here also yz function is this much. So these two are same. So I'll write only for ones, y square z square. Similarly, you need to find function in x comma z. So now what I'll do, except second equation, I'll compare function of xz in the remaining two equations. So any xz function is there in the remaining two equations? Only xz should be there. That should not include y. Any such equation is there?
No, sir.
So that term is not there. When that term is not there, you have to keep it 0. Okay. Similarly, f3 of x comma y is equal to how much? So xy function, except in this
X square, y square.
yes, you should not check in this equation, you have to check in these two equations. So I'll get x square y square available here, x square y square available here, and these two are same. If these two are same, you can write only for ones. Fine. Getting right? So therefore, the required scalar potential is phi is equal to, suitable equation is second one, because f2 0. So this much will be the final equation. X square y square plus xyz plus y square z square. So this is the unique phi value which gives the function f as this much. This much. Fine. Is it fine?
Sir, how did you write that scalar potential, sir?
Any one function you write, phi value, by substituting this one or this one or this one. Any one equation you write by substituting these functions.
Okay, sir.
Any one equation you write by substituting f1 or by substituting f2 or by substituting f3.
Sir, how did we get that x?
Huh?
How did we get that xyz?
Which xyz?
In the middle, at last scalar potential is.
This what I did is take this equation. Okay, what happens? X square y square xyz is there. Okay, plus I have to substitute f1 of y comma z. F1 of y comma z I got it as this much. I substituted. So this will be the unique function. This function is completed, right? Getting?
No, sir, I didn't get it.
What's your doubt actually? You need to
Like-
find value of phi. That is correct now?
F1 we found, I understood. F3 we found. F2 0.
F2 0.
0. Xyz
So,
from where I'm still not getting.
here
Sir, can you say
XYZ.
how is F2 0, sir?
There's no function similar to it.
Function similar to xz function in the remaining two equations. So xyz is not a function of xz. Okay, it contains y also. Okay. So we'll get no function for x comma z. So we'll get 0. We have to write 0.
You have to find terms only with xz, sir.
Huh?
You have to find terms only with xz.
Only xz
Okay. Thank
in
you.
the remaining two equations.
So then how to find phi, sir? Last square potential.
Phi means any one equation you write phi. This phi only we are finding, na?
Yes, sir.
So here this is unknown. This unknown is calculated here.
Okay.
You have
Understood.
substituted it. That's it.
Yes, sir. Yes, understood. Thank you, sir.
Because you are adding f1, f2, f3. Is it?
No, I'm not adding, sir. We are comparing and we are giving the value of phi. No.
You asked how we got x, y, z.
Yeah. How we got?
This
You
is there,
can't
na?
find
Any
phi,
question?
bro. You find all the values F1, F2, F3. Then you put the value there. Taking one
You have
equation.
substituted in this.
Yeah.
That is what.
Okay. Like that.
Yes. Fine.